what is the difference between your Oracle solution and the other most known projects in the market, such as obviously Chainlink comes to mind?
You got to give credit where credit's due. In the terms of Link, right? They were one of the first. They weren't the first, but they were one of the first to bring an Oracle solution to the marketplace. They've done their contribution and they're still evolving into their new model and such. There are some serious limitations though in their traditional model, which includes when you have nodes that are in their individual clusters, like a group of 9 nodes here, a group of 20 nodes here, and it's not a unified fabric, so to speak. You have a situation where those nodes, they are colluding eventually. I know some of them are in the same Slack group together. Some of them are the same operator under different names. These are things that they're hard to prove, especially if all they're doing is delaying the reporting of the data, reading the data first and then trading against it and then pushing the data forward. These are types of scenarios that are hard to prove. Of course, if they publish wrong data, that's very obvious. But the other types of attacks are a little bit harder to prove. I'm not accusing anyone of anything, but I'm just saying fundamentally, it's clear that given enough time, it becomes very game theoretically unstable, that a small set of nodes that are never changing eventually we'll start to collude. And we've seen this in the traditional financial world. We had the LIBOR scandal, this in 2008, where some leading banks, they would collude together to adjust the kind of interest rates reporting information. And that had massive ramifications to the entire financial ecosystem. It's known as the biggest scam ever. So that is basically when your data provider is colluding together to get that information into a smart contract. So our solution is to engineer out the ability to do that in the first place. How do you do that is randomization. So in our system, our nodes are organized into small committees called clans. All clans are the same size, 13. Clans collectively form together to create tribes. So tribes are like a set of clans together. We have multiple tribes. The way that our system works is we utilize something called verifiable random functions, VRFs, to cycle, randomly select a random set of tribes, randomly select a set of clans from those tribes, and dispatch them to the data sources directly. So we do integrate directly with several exchanges. It's the most popular exchanges, directly to the WebSockets, as well as we work with other data aggregators. These nodes on the clan level at the data source run consensus, and then they report it to our block producer, who aggregates the results and publishes the middle value according to like the 15 out of 21 sources. The key is this though, every approximately 12 hours, the nodes themselves and clans are reshuffled into new clan formations. So you don't know who your peers are going to be in your clan. You don't know who your peers are going to be, which clans are going to be dispatched to the data sources. This unpredictability, as long as our network is majority honest, gives us these extremely strong security benefits as well as performance benefits in terms of parallel processing. So that's at a high level, like from the Oracle perspective, how we're different. And there's a lot more to share about I can go into, but before I do, please maybe have another question.
No, I'm just fascinated by what I'm hearing. Please continue.
Sure. There are some new Oracles coming to the table today, and I had a wonderful time enjoying, I actually enjoyed reading their papers. Now, some of these are pretty well thought out. Some very smart people have worked on this. Once again, you got to give credit where credit's due. These models are primarily based off like economic game theory, though. So staking as like the deterrent. It's always better to have a cryptographically secure network. That's always the best. That leverages economic security through staking versus just having mostly a economic security guarantee, which these other two protocols both mostly rely on. As a consequence, what happens is there's a little bit of a relaxed sensation or feeling of maybe we're not as secure, but we have insurance. But the moment you do that, you do, as mentioned, you do tend to relax the security guarantees. But blockchains are composed of smart contracts. They compose with each other. They interact with each other. So the thing that these other projects that are missing in terms of saying, hey, we have this model, it seems relatively secure, maybe not as secure as what you guys are doing at Supra, but it's secure. And in case there's a problem, there's insurance. The problem is with their insurance model is that it only pays out the first protocol that is engaging with the Oracle data. They don't take into account the second order effects. So meaning one protocol gets wrong data, malfunctions, another protocol composes with that protocol, it reacts differently, accordingly, can have cascading failures, but they're only willing to pay out the first layer. So this is something that they're missing, and it's not something that they're not going to be motivated to pay out multiple layers of it. So really, the answer is you just never get bad data into a blockchain in the first place. That's the actual goal.
I am going to cut you there for a second because I never thought about that problem. I've had people that offer solutions for insurance on DeFi here, and I don't know what they think about this issue. What do you think it would be like the worst case scenario? Yeah, should something like this happen, like a faulty uninsured contract just resulting, I'm thinking catastrophic losses here, right? Just due to composability and just like the lowest leg of luck suddenly disappearing.
That's the thing. It's hard to quantify that directly, but I know that in certain scenarios, especially if DeFi were to reach its maximum potential, putting bad data into a blockchain and having these smart contracts react to bad data can have cascading failures. And that could be pretty devastating. Like positions could be liquidated incorrectly, things like this. So really, you have to take the extremity of protecting the data that enters a blockchain in the first place. That's why, it's, in my strong opinion, it's always better to create a network that is cryptographically guaranteed to be secure versus leveraging economic principles as the security model. Those are fun in terms of staking and utility for the token, et cetera. And of course, we're a proof of stake network too. We have great token utility as well. Nonetheless, I'm just going to be kind of general audience that you want to have a cryptographic secure solution for blockchain. Otherwise, these, like I said, second order effects could be really hard to swallow in the future. So, like, once again, insurance sounds great. Sounds like, yeah, we'll handle like most edge cases through insurance, but that only handles the first layer, not all the other.